Now we're going to talk about ways to measure an angle. And we're going to start with the radian measure of an angle. So the definition of a radian. 1 radian is the measure of a central angle theta that intercepts an arc S equal in length to the radius r of the circle. So if you have a radius you have a circle of radius r, as I've drawn here, and you draw an angle in standard position. So we've got a ray here on the positive x-axis, okay, and then another your terminal side. You can see that this here intercepts an arc. All right, the arc that we're talking about is this arc right here. Okay. So that arc right there, we'll call that S. And we're saying that 1 radian is when the length of that arc is equal to the radius of the circle. In other words, if this right here is 1 radian, okay, 1 radian, which we generally abbreviate as rad, okay, an angle of 1 radian is the angle that creates that arc that's equal in length to the radius. And that's, in many ways, is a very powerful way to measure angles. And it gives us this cool formula here, where the measure of the angle you can get by taking the length of the arc that it intercepts, dividing by the radius of the circle. And what's nice is it actually doesn't matter what size circle it is. Okay, it's going to be the same angle. So if you choose the radius r to be 1, then if you think about a circle of radius 1, then the length of that arc will just be equal to the angle that sweeps out that arc. We also have the degree measure of an angle, and this is perhaps more familiar to you. A degree is simply defined to be a rotation of 1/360th of a complete revolution about the vertex. Okay, and so you take the circle and divide it into 360 equal parts, and one of those parts gives an angle measure of 1 degree. There are various theories about where this measure comes from, because it's not nice like the radian. It's not, a nice obvious geometric interpretation of what the angle is. But there are multiple possible sources of it. One is that the approximate year, calendar year, would be about 360 days, and so you think about the Earth traveling around the sun in a nearly circular pattern, then in 1 day it would go about 1 degree. That's one theory. There are several others. So that's the definition of a degree. Both systems of measuring angles are common, very common in certain fields. One measurement is more common than the other. But because they're both so common, we want to make sure that we're comfortable converting between the two. So there's some important things to know about radians, and in order to get the conversion. What we're going to do is look at a circle here, and I want to point out that we know if the circle has a radius of, and I'm just going to do a circle of radius 1, okay, radius 1. We know the circumference of this circle is 2 pi times the radius. So 2 pi is the circumference, and that means, okay, because of the definition of radians, that 2 pi radians is the radian measure of the full circle. But we also know that a full circle is 360 degrees. And so this is the conversion that we're going to be using. Now what that means is if we divide by either one of these, we'll get a unit, we'll get 1. Okay? So for example, if I divide by 360 degrees, 2 pi divided by 360 reduces to pi divided by 180 degrees. That's radians. That's equal to 1. This means that if I have a degree measurement to convert from degrees to radians, I can multiply by this unit, pi radians over 180 degrees, and the degree unit will cancel and we'll end up with a radian measure. You can flip that around, which you obtain by simply dividing both sides of this equation by 2 pi, and you get 180 degrees over pi radians as a unit that you can use to convert from radians to degrees. I want to point out that you'll notice in these fractions, it doesn't say rad, it doesn't say radians, and that's a convention that if we're talking about angles and you don't write a unit, then the unit is radians. So we can kind of truncate the things we're writing by not writing the rad. So let's look at a couple examples here. Convert 135 degrees to radians. So we take 135 degrees. To convert from degrees to radians, we're going to multiply by pi divided by 180 degrees. And now we just need to simplify. So 135 divided by 180, 9 goes into both of those. It goes into 135, 115 times, and 20 times into 180, and 15 over 20 is 3/4. This becomes 3 pi over 4. Okay. Note that the degree symbol, that unit, has canceled here. Okay. And so we have 3 pi divided by 4. This, because there's no unit stated here, we know it's in radians since we're talking about an angle measurement. We can also convert from radians to degrees. So convert negative 7 pi over 6 radians to degrees. So to convert from radians to degrees, we're going to multiply by 180 degrees divided by pi radians. And then we just need to simplify this. Notice that the pi's will cancel, which is nice. 180 divided by 6 is 30. And so we get negative 7 times 30, which is negative 210 degrees.